Imagine that you're in a technical discussion with your teammates and you come up with this block diagram on the whiteboard. Think how easy it would be if you can just take this image and pass it through a code, and with just one click you could get a Verilog skeleton with all these as the input ports and these as the output ports with the correct bus widths, along with this being the name of the file and the module. That is exactly what I'm going to demonstrate in this video. With that, hello and welcome to this video. My name is Badri and I love to explore the use of AI in the world of semiconductors. For the sake of this video, we will be using Microsoft Azure's AI Vision tool. You can use this with many languages and I will be using it with Python, and I will use their API to extract text from images. They have a ton of documentation here. You can read about all of these, and I'm not going to go into the detail of that because that is not the purpose of this video. However, I will demonstrate how the result looks using a simple image. With this simple example, I want to show you the performance capabilities of Azure Vision. Here you see a bunch of English text randomly sprinkled across, along with some random shapes and also stuff written on the back side of the paper. Now I will run this through a text extraction code in Azure Vision and we will discuss the results obtained. Here's the code that I will be using to extract text from our sample image. Before proceeding, I would like to mention that if you want to run any of this, you will have to get a subscription from Azure. It is free when you sign up for the first time, and they will give you $250 of free credit, which you can use to run a lot of projects. With that, I will proceed. Now you load in the image file, then you set a bunch of options. So Microsoft Vision can do many different feature extraction, and in this case we are only worried about text, so I have just enabled the text extraction part. Say I have set the language to be English, and then we analyze the image here, and once the image is analyzed, we will go ahead and print the lines extracted, the words extracted in each of the line, and then we will also look at some of the coordinates of where they are. I will go ahead and run this code. As you can see here, we have received our output. Here it says the first line is just cat and the word associated is also just cat. Then the second line it reads is rat, the word associated is also rat, and you can see here that something else is read as one line even though there is a space between the two words, and you can see that the individual words have been split apart as something and else. And yes, I do agree, we did get a few false positives here from the arrow symbols that we had. It has interpreted them as dash and the greater than symbol. We will see how to eliminate this in a bit. Moving on, we do have the bounding polygon. What the bounding polygon is a rectangle with x and y coordinates for each of its edges. This is how we know the position of where the word cat is, then the position of where the word rat is, and so on. And the third output we have here is confidence. Now if you see, the word cat has a confidence of 98%, which means that the tool is 98% confident that the word is cat. However, when we look at these two words that it has extracted here, the confidence level is 75%. As a rule of thumb, I always use anything above 85% or 90% as a correct number, and anything below that as something to ignore. And using that logic, we can safely ignore these two here, which are both well below 85 to 90%, and then you can see that something and else are also having high degrees of confidence. With this knowledge, we can know the positioning of the input ports, we can know the positioning of the output ports with these coordinates, we can get the names of the ports, and from then on we can just do some basic scripting and extract the code that we want. I will show you that right now. As we discussed initially, this will be the block diagram for which we want to create a System Verilog skeleton. Now I will go through our code and I will give a quick run through of the explanation of the code on what it is doing, and then I will show you the final result. We have set up the code in the similar way as that of the sample image. Once the extraction is done, we will get a string of words along with the bounding polygon. These are going to be the XY coordinates of the four edges of a rectangle which are drawn around every word that is extracted. Now we can use these coordinates to determine if the word extracted lies on the left side of the block diagram, or in the middle of the rectangle in the block diagram, or if it is on the right side of the block diagram. If it's on the left side, we call it an input port. If it's on the right side, we call it an output port. And if it's in the middle, we use it to create our block name and the file name. Once we have all of this, we can just do some basic Python scripting to extract the bus widths by checking for the presence of rectangular brackets and what is inside the rectangular brackets. Then it's just a matter of printing the statements into a text file to create our Verilog file. Now I will go ahead and run this code. As you can see here, we have generated a file that is called digitalcontrol.v. As you can see, the name is the same as that of the block in our block diagram. If we open it, we notice the input and output ports are well formatted, and the name of the module is the same as the name of the file too. Any logic that we want to add to this skeleton can go here. And as a sanity check, we can keep note of the bit widths used here. We have a 4-bit input 1, 24-bit input 2, and a 12-bit output 3. We will just verify this once in our block diagram now. Here you can see from the diagram that input 2 is 24 bits and output 3 is in fact 12 bits. And so was the case with input 1, which was 4 bits wide. With that, you can see that we can pretty much generate an RTL or System Verilog skeleton file by just passing this block diagram as input and obtain a well formatted input port list, input and output port list. With that, we have come to the end of this video where we saw how we can use AI to generate a skeleton of a Verilog file using just the block diagram which is handwritten. For more videos on how to use AI in the world of semiconductors, please stay tuned for more videos from me. Until then, enjoy designing and see you soon. Thank you. Cheers.